Hi, so today we've got an S23 Ultra with us for data recovery. It's already been to another shop and I have it currently disassembled and on my desk. So this is the S23 Ultra motherboard. It came in showing no signs of life. The phone's not water damaged, and the other shops tried all the basic troubleshooting steps such as trying to power it on with a known working battery and all those things. The phone doesn't power on. Now, when I connect it to the DC power supply, it has a 50 milliamp current draw, and when we prompt it to boot, it shows no signs of life. Let us try and fix it. All right, so the phone is currently under the microscope. I have the DC power supply plugged in. I have the DC power supply set to 4 volts at 4 amps. Let us see what happens. Now, as soon as we turn on the DC power supply, it has a 46 milliamp standing current draw. It should have no current draw when it's in this state. And let's see if we're getting any voltage at the power button. So these are the test points or the connection points for the power button with one probe on ground and my multimeter switched on. If we measure the voltage at the power button, we get, oh no, this is the power button, sorry. We get 3.6 volts, which is less than the 4 volts we're supposed to see over there. Now, let's see what happens if we prompt this phone to boot. So if we prompt it to boot, nothing changes. Let's check again. Yeah, it's stuck at 3.6 volts. Let's see how much voltage we get at the resistor right after the power button, or right after the battery connector. So if we check this resistor right over here, let's make sure that's plugged in, we get 3.987 volts. And I don't know if I was able to show it on the microscope, so I'm gonna make sure the microscope actually sees it. And then if we check the voltage at the power button, it's sitting at 3.5 volts. But if we prompt it to boot, there is no current draw whatsoever, so it doesn't react to a power button press. Now, let's see if we have the main input voltage showing up on the board. We can check that right here where the charging connector is. I think, no, this is the LCD connector, but these two capacitors in the corner are the main voltage capacitors. So if we check the voltage here, it just shows 1.8 volts. So that is definitely not correct. Here, I'll make sure it's plugged in and seated properly, and we'll check again. So we're definitely not getting main voltage on the board. Let's take a look at the schematic and see how the power rails are routed. So if we look at CXW tools, this is the S23 Ultra schematic, and this is the positive pin for the battery. It comes in from the battery connector, and then it goes through to this resistor, R14100. This line is called V-Battery CSP. It goes through the battery connector and then appears on the other side of the sandwich board. Now, if we look at side B, it comes to these two chips, U5200 and U5202. From these chips, it takes in the voltage from the battery connector, and then it puts it out as VPH power that goes through to all of the components on the motherboard, including these two capacitors where we measured only 1.8 volts. So that tells us that the main voltage from the battery is not making its way through the board properly. So we're going to take the shield off behind the CPU, or we're going to take the shield off that's protecting the CPU, and we'll check the VPH power line to see what's going wrong. Now that the shield has been removed, let us check the components around the two power management chips. So the Max IC, and I forget what the other one is called. It was U5200 and U5202. Let's check the components around those in diode mode, and we'll see if we can spot a short circuit. Okay, so this coil is showing a diode mode reading of 0.075 voltage drop to ground, this guy right here. And just looking at the traces on the board, we can see that it connects directly to Max 77705C. Let's check the schematic and let's see if that's the case. So if we look at the schematic right here, that is the coil that's connected to VPH power. One end connects to the Max IC, and then the other end connects to the board, and it goes all over the place. So it's definitely not supposed to have such a low diode mode reading. What this tells us is that we could have a short that's on the other side of the board, so possibly in the sandwich board, or we could have a short that's just on the Max IC, which would be easy to fix. We may also have a short-circuited capacitor. So the easiest way to confirm if this is a short circuit on the VPH power side or if it's a short within the Max IC itself is to disconnect this coil and see which side has the lower diode mode reading. So let's do that. So in order to remove this coil as safely as possible, because we don't want to overheat the CPU, which is right on top of it, is we'll put some low melt on this coil, and we'll use low hot air temperature to take it off. And we will also heat sink the CPU with this copper pad in order to make sure it doesn't overheat. So we'll first start by switching the fume extractor on. And then we'll put some low melt on the coil. Now this side of the coil is easily accessible. However, we've got some components on this side, so I'll show you how to get some low melt on that side as well. We will not use the iron to put low melt on there, but instead we will take some low melt off with the help of our hot air. And then we'll put that solder ball right here on the base of that coil. And as the low melt melts, it will just absorb into the base of this pad. There we go. And this should allow us to remove this coil before everything else. Now I may need more low melt in that area, so we'll remove the hot air until the low melt kind of solidifies. And then we'll take a bit more and pop it there in the corner. And now we should be able to take this off with relative ease. Voila. All right, now that the coil is off, let's cool the board down. Well, we'll check it first before though while the board is still hot, it won't give us accurate readings because while the board is still warm, the diode mode readings will be lower. But if we check the VPH power side of the board, that still has a low diode mode reading, and the IC side is okay. So 0.226 on the side of the IC, and VPH power is 0.085. That is not good, because that means the short could be inside the sandwich board, or it could be on this side. So the next step would be to solder a wire to VPH power and check it with the thermal camera. Okay, so I've soldered a couple of wires to the partial short circuit, and I have it connected to the DC power supply. We're going to inject 4 volts into that line, and we'll see what heats up. So I have the thermal camera ready. Let us begin. So it draws a very low current, 164 milliamps. There is a hotspot near the UFS. Let's turn the DCPS off. The current goes away. Let's turn it back on. And the current and the hotspot reappears. Let's try that again. So based on the even heat bloom, I think that short circuit is inside the sandwich board. Now, just to be thorough, let's take a look at the other side of the board, and we'll see if anything shows up here. And no, all the heat is inside the sandwich board. We got nothing on this side. Let's try that again. So based on this heat signature, it looks like the short circuit is inside the sandwich board. These boards are a pain in the butt to split, so that is not good. Okay, so I've decided what to do with this board next. To solve the partial short circuit on the board, we will have to split it, but the biggest problem with Samsung boards is the UFS 4.0 is extremely sensitive to heat. And the board takes a massive amount of heat when we're splitting it. So in order to ensure that the data remains safe, I've decided to take the UFS off first, then we'll split the board, solve the short circuit, and then put the UFS back on. Now, because I've taken the shield off already, there's a chance that the CPU will overheat as well, and we're going to have to reball the CPU also. We've got a long job ahead of us. Let us begin. Okay, let us begin. I have the board on my board holder. I've heat-sinked the CPU and RAM. The hot air station is set to 390 Celsius at 80 airflow. Let us begin by removing the UFS first. Once we take the UFS off, we'll test it. We'll make sure that it's not damaged in any way. And then if the UFS is good, we can proceed with the next part of the repair. So I'm just going to preheat the area a little bit in order not to thermal shock it. So when preheating the board, I have my nozzle about 2 to 3 inches away from the board, and I'm moving it in wide circles in order to make sure the entire board is brought up to temperature. It just needs to be reasonably hot. So I'm going to preheat it for about a minute or so. Now, while we're preheating it, I'm going to I think I'm going to clear these solder pads because we want to make sure the removal tool is as flat to the board as possible. All right, now we can begin. So let's preheat it a bit again. So the biggest problem with the UFS is that it's extremely sensitive to heat and also bending. So if you pry on the chip as you remove it, that pretty much guarantees that it will just get destroyed. And if you heat it for too long, you guarantee that it gets destroyed as well. So the safest way to take it off is to first insert your tool under the UFS just so you can feel where the underfill is. And then it looks like on this guy, it's pretty much right on the edges. So that kind of makes it a little bit more difficult. So now I'm going to put some flux all around the board. It'll just help the UFS come off cleaner. And now let us go in. So I'm going to move my hot air in wide circles, and I'm going to start trying to slice the underfill immediately, because the goal is to go in and be able to feel the solder pads under the UFS so that we can start removing it as soon as they melt, like right now. And it's off. Took off a couple of components on the side. It's not too bad. We'll be able to put them back on immediately. So I'm going to lower my hot air to 370 Celsius at 50 airflow. We'll put this capacitor back, and then I'll look for that inductor on my desk. I think the other guy was a cap as well. Okay. It is so aggravating when this happens. I was a little too nervous when removing it, so I ended up poking it a bit too hard. And I knocked off that big capacitor. Just checking to see if it's on here. So this is the UFS. We've got no pulled pads. It came off pretty good. So we'll clean it and we'll test it, but I would like to put that component back. So I'm gonna search for it quickly and put it back. Just give me 1 second. I think I'm gonna pause the recording while I look for it because this is just, it's gonna be pretty boring while I look on my desk. Well, as aggravating as that was, I was lucky. I managed to find that capacitor. Thank goodness. So we're gonna put it back on the board. The craziest thing is it flew quite some distance. I'm just amazed that I actually managed to find it. I feel lucky as well, because finding a donor board would have been painful. I suppose not so painful. Probably still would have been able to find it, but still. Next step is let us clean the pads on the board, and we'll clean and reball the UFS, and then we'll test it. Now, in braiding the pads on the board, always be extra careful that you're not pressing down with the braid too hard. Otherwise, you'll end up pulling pads or you'll scratch the surface of the PCB. Now, we need to remove these underfill pieces. Otherwise, that will that won't allow you to put the UFS back on properly. So we're going to set the hot air to 265 Celsius at 60 airflow, and then we'll use the underfill removal tool to gently scrape off the underfill from the board. I make sure not touching, they're not good. Okay. Just gonna use the foam scrubber to pick up any excess underfill left on the board. Make it nice and flat. Perfect, this looks good. Gonna remove that speck of solder. There we go. All right, so the board is ready. Just gonna give it a quick toothbrushing and make sure it's properly clean. So I'm gonna tin the pads on the UFS and braid them. Now I can already tell that a good bit of underfill is left on the UFS, so that will have to be cleaned. Now you have to be extra careful when tinning and braiding the UFS, because if you scratch the PCB on the UFS, you can easily damage it beyond repair. I've seen some horrible looking UFSs come into my shop after prior board repair attempts by other technicians. I actually uploaded a video of one of these on my channel where the UFS was damaged beyond repair and data could not be recovered. Got two pulled pads on here. Damn. I'm guessing we pulled those off when we took the UFS off. We'll have to check the board view and confirm that they are not needed, but that is not good. Yeah, those pads are not there. Damn. Okay, so with the hot air set to 265 Celsius at 60 airflow, all right, the UFS is cleaned. Let us reball it. I'm going to use 300 Celsius at 60 airflow to reball the UFS. One solder ball that didn't quite attach. There we go. Move stencil. Perfect. I will reflow these guys and then we'll clean it. I'm very upset about those two pulled pads. I think they got pulled because I went in too early when removing the UFS because I wanted to avoid overheating it. Because that is genuinely a very big risk with this chip. It'll survive pulled pads, but it will not survive overheating. But it's funny, as I was saying that it's so easy to pull pads, I end up pulling two. Suppose it makes for a good lesson still. Okay, we've confirmed the ball height. Now let's plug this in and check it. All right, so first things first, let us check ZXW tools for these two pads that were pulled. So it's A1 and B1, and they're both ground. So we were lucky, nothing important got damaged. Now let us plug the UFS into the JC programmer and we'll see if that works. Okay, the chip is detected. Excellent. It is alive. Now I pause because we want to make sure that the chip backs up fully and reads. So let us back up the chip, including the user data folder. And the read speed is 160 Mbps, well, 150, which is good. The chip is working normally. Phew. So the most stressful part of this job, well, one of the most stressful parts of this job is done. Next step is to split the sandwich board. We'll wait, we'll make sure that the backup completes successfully. But Lun 0 is typically the one that gets damaged if the UFS has been damaged either because of heat or bending. So with this, we can confirm that the UFS was removed successfully. Fantastic. The UFS reads and backs up successfully. It is in good health. Let us proceed with the board split now. All right, let us begin with the removal of the sandwich board, or splitting of the sandwich board. I currently have my hot air station set to 400 Celsius at 100 airflow with no nozzle. So the trick with this is to remove or to split the entire board without bending it or warping it, and also without overheating it. So the challenge is the board is pretty oddly shaped, so it is extremely difficult to split it all at once the way you would an iPhone or a BGA chip. So we have to do this section by section. Now, the trouble with that is if you split one section, if you focus the heat in just one area, you will warp the board. So you still have to heat it evenly. So the trick is to keep the hot air moving at all times. You cannot get stuck in one spot. Doing that is a recipe for disaster. You will cause spot heating, which is not good. If you spot heat the board, it'll warp, and you might even delaminate the layers. So you keep the hot air moving. You keep it approximately 1 inch to a half an inch off the board. Now, when you're doing this, be careful that you don't bump into components. That's very easy. Now, once I've heated the entire area generously by moving my hot air in wide circles, see, I just bumped it into the board there, but we're still too early, so I was okay. Now, this right wing on this board is the one that detaches first, just because that has the lowest thermal mass. So that's why I'm focusing my tool in that area, and that'll tell me that it's ready to start coming off. As soon as the solder melts in that area, my tool will just slide in. When that happens, be careful that you don't go in too deep, because if you do, you will cause damage. You'll knock components off in the board layers themselves. Now that the board's warmed up sufficiently, we're gonna go section by section. So I'll first split the wing, and then we'll move on to the other side. Now, when going section by section, I still like to take time to go over to the other sides as well, because we want to make sure that we heat the whole thing evenly. And you do not want to force your tool in. Once it melts, it'll go in pretty easily. There we go. So now the wing is starting to split, which means we can move to the other section of the board, which is right here. Now this area is split, but this area here is not. All right, so this area is starting to split, which is good. All right, so it is properly up on the wing side. Now we can just focus on the main board. A little bit of the wing side is still not up. That's making things a little more difficult. There, now I can see it coming up. Excellent. So I'm gonna come in from here. Excellent, excellent. And it's off. Wonderful. Oh, that is quite hot. All right, let's inspect it under the microscope and we'll make sure that we've not lost any components or pulled any pads. Beautiful. This looks good. I don't see any pulled pads. All right. Let us oh man, this board holder is so hot. Oh, 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 that hurt me. Oh, that was so hot. Okay. If we look at the board, all the components look intact and undamaged and undisturbed. Wonderful. Oh, just this guy at the top got budged. Let's put him back. So we're going to put a bit of flux on there, and then we'll use low heat to put him back on. We use 370 Celsius at 50 air. Oh, hold on. 370 Celsius at 50 airflow. And we should just be able to push it back in position. There we go. Wonderful. Now let's look at the back side of the board and make sure nothing got disturbed. Now right here in the corner, I feel like we have a solder ball that popped out. That's from under the CPU. So as expected, we will have to reball the CPU as well. I mean, there's a chance that the CPU is okay and it doesn't need a reball, but based on the fact that we've got two solder balls that got squeezed out, it's better to reball that guy than to deal with issues where we put the whole thing back together and it doesn't work. And we'll fix that as well. But yeah, all in all, I would say this was a perfect split. Wonderful. Wonderful. Board holder gets so hot when doing this. Yeah. Now, in order to make sure we don't overheat the CPU, I'm going to wait for the board holder to cool down just a little bit. In the meantime, let's go ahead and tin and braid the pads on the bottom board and get it prepared for a reball. I'll move the board holder out of the way. Looks like that may have come off a little bit, so we'll pop that guy back down. Let's make sure. I want to say that looks okay. Don't need to mess with it, but The wing is slightly askew. We'll reflow those two and make sure they're attached properly. But otherwise, the bottom board looks good. So here, we'll put a little bit of flux on here and on the bottom board. And then we'll reflow both of those components. I'm going to use 390 Celsius at 80 airflow. And we'll just reflow the wing and nudge it so that it surface tension pulls it into place. Perfect. Let's make sure we're doing it once more. Yeah, that's good. And then with this guy, we just push it down a little bit, and that's good. Okay, so the wing has been adjusted. I'll switch on the air filter because I was breathing in flux during that time. And then we'll put flux all over the bottom board, and then we'll braid and tin it. Now, while I'm moving the board around, in order to make sure it's in view, I'm just going to zoom out slightly. And let's begin. So first, we're going to tin the board with some low melt. The low melt solder makes the job of braiding a lot easier. So once you've tinned it with low melt, when you go and braid it, the braid just glides over all the solder and picks up everything quite nicely. So low melting it and braiding it is the way to go. Now, honestly, the hardest part of this repair is now over. Now that we've tinned in, now that we've split the board successfully without losing any components, we're in the clear. So we just need to remove the CPU, reball the CPU and UFS, and then it's just putting it back on. So the process, or the order of operations is going to be, we will, hold on, let's make sure this is in focus. So the order of operations we'll follow is, we'll first prepare the bottom board by tinning it and braiding it. Then we will remove the CPU and we'll prepare the top board by tinning it and braiding it. And then we will reball the CPU, UFS, and RAM. Then we'll put the top and bottom, then we'll clear the short circuit. Then we'll reball the top and bottom board and put it back together. Then, once we've confirmed that the short's gone and the board's okay, we will put the CPU, UFS, and RAM back on, and that should fix it. All right, let's clean the board. We've got one stubborn solder pad here. So I'm just gonna scratch it and get rid of the oxidation. There we go. Wonderful. Bottom board has been prepared for reball. Now the board holder has cooled sufficiently, so let us go ahead and remove the CPU. All right, so to remove the CPU, I'm going to use 400 Celsius at 80 airflow, and I'm going to use the same temperature to remove the RAM as well. I'm going to put some flux around the pin code IC in order to make sure it doesn't fly away. And let us begin. So the technique for removing the CPU and the RAM is largely similar to the technique for the UFS. We will keep the hot air moving in wide circles, and we'll insert our IC removal tool and feel the underfill. As it softens and the solder melts, we will just slice inwards and take the chip off gently. All right. Now that the RAM is off, let's do the same thing with the CPU. And it's off. Come on. All right, the CPU has been removed. Let us fix the pin code IC and the components around it, because the CPU bumped into those and kind of nudged them. We're going to use 370 Celsius at 50 airflow to put them back where they were. Perfect. We'll fix those guys once we've cleared the excess solder from that spot. Now, while the board is still hot, we're gonna tin the pads on the board with low melt and braid it and clean it. Now, one of the capacitors on the CPU came off, that guy. So we'll remove it and we'll set it aside, and then we'll put it back on the CPU after. It's got too much solder on it, but we'll fix that after. Let's put some more flux on here. And then let's tin it and braid it. No idea where that tiny guy is from. Gonna have to take a look around and put him back where he belongs. Strange. Because all the components around the CPU look like they are where they belong, so... Oh, I see where you're from. Okay, let us fix those components that got budged around the CPU. So we're gonna use 370 Celsius at 50 airflow. Make sure it's in focus. That is always so annoying. Let's zoom in a bit so that we can see better. And let's see if we can split it once again. Perfect. Zooming in did the trick. Okay, that's good. And I think this zoom level is good enough for grading and tinning the board as well. This way I can make sure you guys are able to see what I'm doing, and it's not too far away where you can't see. Just the right angle. Let's begin by braiding the board when cleaning whatever underfill is under the CPU. Now, it looks like the CPU did not have too much underfill, which is good. It makes life easier when cleaning the board. And again, perhaps I didn't need to take the CPU off, but the risk is if I didn't take it off and it was overheated, it would just be so much work to redo it all. Because then at that point, with the CPU on the board with high temperature solder, it would take way too much heat to take it off again, which would mean that it would mess up the sandwich board reball. So instead of having to do the whole job twice, it's better to just do a little bit of extra work and do it all in one go. Because don't forget, we still have to clear that pesky partial short circuit on this board as well. All right, let us clean the board, and then we will tin and braid it again if need be, but looks pretty good so far. Wonderful. Got a little bit of underfill left on the board. Let's clean the underfill, and then got a few pads in the center that seem to have some extra solder. I'll show you a handy trick on how to clear that. So what we're going to do is put a bit of flux on the board, and then we'll come in with some moderate heat. So 370 Celsius at 50 airflow will do. And then once the solder pad melts, we'll just brush it with the braid, and that will be enough to pick up the excess solder that's on there, and it'll make it look nice and shiny and flat. Beautiful. Now let's get rid of the rest of the underfill. It's just a little bit left in these corners. And I might fix that PCB mask that came off, though it's too tiny, so it shouldn't make a difference. Especially because it has not gotten tinned. I think I might be better off leaving it be, but we will clear the underfill in this corner here. So I'm going to use 265 Celsius at 60 airflow, and I'm just going to gently scrape it until all the underfill comes off. Whoops. I don't know if we have enough solder left on those pads. Okay, so what we're gonna do is I'm gonna take some leaded solder on my pin. We're just gonna deposit a little bit of that stuff on the component itself. That should be good enough. We'll increase our temperature to 370 at 50 just to make it quick. And there we go. Perfect. Let us pick up this excess bit of solder on the pads here. There we go. Oh God. That was my fault. God damn it. That's the risk when you use the braid technique. If you're not careful, you can cause unnecessary problems very, very quickly. So now we're gonna have to fix this. All right. Phew. That is done. Okay, let us quickly fix these solder pads with our healed iron and braid. Make sure all of the extra solder has been picked up, and then we'll clean the board. Excellent. Oops. Okay, let us clean the board with a toothbrush and alcohol. We'll fix that guy as well while we're at it. Just because we don't want to forget, and then it's one less thing we have to do later. There we go. Now let's scrub the board with a foam cube just to give it that final clean. We'll get rid of any underfill remnants, and now the board is ready to accept the CPU. Just a little bit of underfill left here in this corner. All right, I'm gonna mask that trace that got exposed just to make sure we don't have any problems when we put the CPU on. But the board looks good. Man, it's so loud. I'm just gonna put a bit of mask in that corner, and then all right. So with the UV lamp, let's cure that trace. All right, that should be good enough. Let us scrape that end a little bit more, or make sure that the solder pads are properly round. That's the word I was looking for. Okay, the solder pads look good. Now let's give the board one last scrub and make it nice and clean, and then we can proceed with the repair. So the best way to clean underfill and flux, they're not under. The best way to clean flux off of the board is to first saturate the board with rubbing alcohol, and then just blow it off with some compressed air. And that does a very good job of cleaning up all of the flux that's on the board. And look, now it looks nice and clean. After cleaning the flux, I do see that we've got a couple of spots of underfill left on the board. So let's go ahead and pick those off with our underfill cleaning tool. Two corners. Then we'll just scrub it clean. Excellent. All right, this looks perfect. All right. Now the next step is to tin and braid the bottom board. Once we've prepped and cleaned the bottom board, then we will hunt for that short circuit. And then once we've cleared the short circuit, we'll put the two board halves back together. And then we'll put the CPU, UFS, and RAM back on, and hopefully it will work. All right, so what we're going to do is I'm going to solder a wire to VPH power, which is the positive, or which is the main power rail for the board. And then we'll solder another wire to ground. And then we'll inject 4 volts into this board and check it with a thermal camera on the other side. And it should show us a short-circuited capacitor, hopefully. Could be an IC chip, but if it's a cap, makes the job that much easier. Let's put a bit of flux on here as well. Excellent. All right, so now turn off the DC power supply, and we'll connect the probes. Okay, I'm going to turn the board around, and I'll zoom out so that you can see. And let me grab the thermal camera. All right, I have the thermal camera ready. Let's record it. And now I'm going to turn the DC power supply on. Look at that. The IC has failed. Of course it has failed. So let's see what chip that is. So the bottom right-hand corner of this chip lights up. Capacitor and those inductors do not. But in order to be thorough, let's check those inductors in diode mode and we'll see if we can spot anything that is not good. So here is the multimeter with the red probe on ground. Come on. And then that guy. Okay, so that capacitor shows a full short circuit. And both of those inductors show a full short circuit. Can't test the top of those inductors. Maybe I can reach the pad with my probe. I cannot. Let's check the other components around this chip. And they all show a short circuit. Of course they do. Now let me check the schematic or the board view and we'll see what that line is. 1 second. Okay, so the line that is showing a full short circuit is also VPH power, though with the top and bottom board together, VPH power showed a partial short. And on the top side of the board, it still shows a partial short. But on this side of the board, okay, it is still showing a partial short. However, that inductor is showing a full short circuit to ground. So VPH power isn't short circuited, but that line or that inductor is. So now there are two ways we can go about this. We can remove that chip and see if the short clears. If that line is still short circuit, that means the IC has failed. And if the short circuit still remains, that means the IC is good and something else is the problem. Let's take another look at that line. So it's VREG S6C underscore S1 underscore S2C underscore S3C underscore 0P75. So it looks like the 0.75 volt power rail has a short, and it just goes to a couple of capacitors and nowhere else. So it goes to these guys here, and visually they all look all right. So the line that has the short is this 0.75 volt power rail, and it goes to these capacitors and that capacitor right there. So if we measure on there, that should also read as a short circuit. Let us double check. So the red probe on ground. Yeah, that reads a full short circuit. So the 0.75 volt power rail is a full short. Now we could inject voltage into that line and see if anything heats up. Or we can take that chip off and see if anything heats up. I mean, we can take that chip off and we can see if that clears the short. And it would just be easier to inject voltage into that line, but the only problem is I don't see any pads that are easily accessible. So we will have to remove at least the inductor to confirm. Now, because it connects to that line with these, wait a second. This pad at the top. Ooh, I almost missed it. Okay, I think we'll inject voltage first. This pad at the top is also connected to that line, so we can inject voltage right there, and we can check for a heat signature. I think that is the best course of action. So let me disconnect this jumper, and then we'll attach the wire onto the other side. I'm gonna need a smaller iron tip. All right. That was a little too close for comfort. Almost touched the hot iron tip with my bare hands. All right, let's put a bit of flux on that pad. We're going to be connecting to the outer pad over here. And then we'll put a bit of flow melt solder on there, and then we'll attach the jumper. All right, that is good.
No, this is the platform. All screwed.
All right. Let's make sure that that inductor is not bridging. No, the inductor is good. Oh, and I broke off the jumper. Durr. Okay, let's put that on once more. Teeny tiny wire. Thing is, the low melt solder is extremely brittle. So it breaks off very easily. That's why it's not recommended to stick components on, but it's good for troubleshooting. Now we're going to adjust the voltage. We're going to inject to 0.5 volts, and then we'll limit the current to 1 amp. And then we'll see if anything heats up. Because that's a full short circuit to ground, we should still have a heat signature. And I'm going to turn off my DC power supply. That's what I was trying to say. All right, let us switch on the DCPS. Oh, we're looking in the wrong spot. Durr. So that inductor on the top right is heating up. And nothing else. And because that line just goes in a few spots on the board, we don't have to spend too much time searching for it. And yeah, I just see that inductor with a hot spot, and then the IC shows a bit of heat as well. I can increase voltage to 0.7 volts because on the board view, that line is rated for 0.75. And just goes under the CPU, and that's it. Because we don't have the CPU installed, we can be sure that the CPU is fine. So let's increase voltage to 0.7 volts. And we'll inject power once again. And we just have that inductor heating up. And nothing else. Let's try that once more. Yeah, and looking elsewhere on the board, I don't see any other hotspots besides that inductor. I think that IC has failed. Now, I could increase the current a little bit more. So let's do 0.7 volts at 2 amps. And yeah, it's just that inductor that shows a hot spot. Okay, let us remove that chip and we'll see if the short clears. Okay, so the pin 1 of that chip is on the top right corner. So what I'm going to do is I'm going to just make a small mark on the board to show us what the correct orientation for that chip is. All right, that X is good enough. That'll tell us that it corresponds to that chip. Let's take it off. So we'll use 370 Celsius at 50 airflow to remove the IC. All right. Now with the chip taken off, let us measure the board and we'll see if the short's gone. Now the board is going to be pretty hot because we just soldered on it, or because we're just blowing hot air on it. So you may not get an accurate reading, like the line is going to show lower than it is. So the IC side of that line is no longer short, and the motherboard side is no longer short either. And VPH power is no longer a partial short. So that confirms that that chip had gone bad. Now I need to find a replacement. So let me search for one and then I'll be back. Actually, before we do anything else, let's just prepare the board for the new IC. So I'm gonna tin and braid the pads on the board. So I'll first tin it with a bit of low melt. This iron is not hot enough. I really don't want to faff around and bridge components and all that. Just like I did there. And there. God damn it. Okay, so we're going to use the hot air technique to tin those pads because my iron is not going to be hot enough to help with that. But this time, in order to make sure I don't float anything else, I'm going to set my hot air to 330 Celsius at 50 airflow. And let us zoom in so that we can see. This should allow us to clear all the solder from those pads, make them nice and flat for the replacement IC. Clean up that guy as well. Okay, let's move the board. Yeah, we're gonna move that capacitor back. Ended up nudging it a little. And we'll lower our temperature to 280 Celsius because apparently that was still too hot. That's the thing, once we split the board, its thermal mass drops a lot. So even temperatures that ordinarily would not have done anything are now hot enough to melt lead-free solder. You have to really know your temperatures and also work based on feel. Excellent. I believe that is good enough. Just that tiny pad in the top corner could be scratched. There we go. That's good enough. Now let's clean the board. The burnt flux. So annoying. Let's use a foam cube to clean it. I think this will be more efficient. Excellent. Let's remove the solder pad here. There we go. Okay, so the board is now ready. To accept a new chip, we just have to find one. I may have to order a replacement unless I can find one on a donor. So let me look for one and I'll be back. Okay, so I managed to find a donor motherboard with a replacement chip. Turns out it is compatible with the S24, 25, and 23 series. So I managed to find the same IC on an S23 and I just reballed it. So this is the chip that has gone bad. And then this is the replacement one, 8550VS. It is the same model. And this has a perfect reball on it. This is the one we just removed that has internally short-circuited. So let us put this chip back on and we'll see if the short clears. Gonna put a bit of flux on the board. And then the orientation for this IC is the top right corner. So just gonna flip it. All right, let us reflow it. I'm gonna use 370 Celsius at 50 airflow. And once the solder holding the chip melts, it should pull itself into the right position. As soon as that happens, perfect, the chip is on. We wiggled it and it moved back. Okay, the chip has been soldered. Excellent. Now, once it cools down, we can check the board and make sure that the short has been relieved. All right, that should be good enough now. So with the red, here, let me zoom out a bit so I can see the red probe on ground. And look at that, the short is gone. 0.296 voltage drop to ground. And if we check VPH power, that is good as well. Excellent. So we have solved the partial short circuit on this board. The only thing remaining is to reball the sandwich board, put it back together. Let us continue. All right, so now the next step is we're gonna reball the sandwich board. So I have the board in the stencil or the stencil holder. Pop the stencil on, and we'll spread a thin paste of low melt solder, or a thin layer of low melt solder paste. Now, when spreading the solder paste, I always like to use this chiseling motion to scrape up any excess paste. Because if you don't do this, it increases the likelihood that you'll end up with an uneven reball. It's always satisfying when you can get a perfect reball on the first try. All right, now the next step is we're going to use a lower temperature because it reduces the chances of the stencil warping. So I'm going to use 300 Celsius at 50 airflow, and we'll start with this corner. Actually, we're going to heat the outside corners of the stencil first. That should prevent the stencil from warping too bad. And now let's go in. And when doing the actual reflow, we'll go in close. You may have to put a bit of flux there to help the solder flow better. It's always the risk when you use dry paste, but it prevents it from being too runny and then just attaching to adjacent pads. So we're going to continue with the reflow. Once we're done, we'll come back and add some more flux and then reflow it again. All right, now let's put some flux on the stencil and then we'll reflow everything, and that should be good. So far, it's not looking too bad. Like some of these solder pads in the, like on the wing here and in this corner here, they definitely look like they have a lot of them not attached. But on the whole, I want to say once we introduce some flux into the board, it should be okay. And what I'm going to do is I'll use hot air and flux at the same time. That should help the flux flow in immediately instead of just resting on top like it is doing on the other ones. I do want to be careful in the corner here. We've got a lot of solder balls stuck to the stencil. All right, now let us begin. We'll go with the corner ring once again. Perfect, that has flowed nicely. And that's flowed nicely as well. Excellent. Awesome. The whole thing has been reflowed. Let's take the stencil off and we'll take a look. So we'll first move it out of the magnetic pad. Then we'll peel the stencil off while it's still warm. Now you don't want to peel the stencil off too soon, because if you do it while the solder is still molten, you'll just end up with a mess on the board and you'll have to redo the whole thing again. But so far, it looks perfect. Excellent. Let me just clean the stencil holder. And then we'll take a look at the board. I'll actually reflow it with some flux one last time to make sure all the solder balls and solder pads are properly attached. So let's do that. All right, so let's add some flux and reflow. Now the rest of the pads on the board look pretty good. Like, it doesn't look like I need to add much more flux, maybe a few corners here or there. Because we put a good amount of flux when we reflowed it on the stencil. So this should be good. Okay, let us begin. Excellent. Okay, once it cools down, we'll clean the flux and then we'll inspect the board. In the meantime, I'm going to clean my stencil quickly. So let's clean the board and then we'll inspect our handiwork. So we'll just scrub it with the microfiber cloth, and that should be good enough. And it is. Beautiful. Okay. And that is a perfect reball. Let us check the ball height and make sure they're all perfect. That is wonderful. All the solder balls are perfectly even. This is a gorgeous reball. I'm very happy with this. Now, I did see an errant piece of dust here that's gone. Okay. We have an errant ball here. Let's get rid of you. All right, now the final step is to put second final step is to put the sandwich board back together. Give it one last look. Inspect all of them. Make sure that the reball is perfect. None of the balls are too big or too small. And they are excellent. Really excellent. Okay, let me prepare for putting the board back together. All right. Let us put the top and bottom board back together. I'm going to make sure it's properly held in place so that it doesn't flop about. Okay, now let's just spread this flux all around. All right, let's put the bottom board on. Let's make sure this does not have any errant solder balls. And it doesn't. Looks clean. Okay, I'll just put it on the board and we'll flow it once again. Make sure it's lined up properly. Okay, now that the board has been reballed, once again, let us put the sandwich board back together. The key is to keep the hot air moving in fast circles. And don't bump the board. We're going to watch for the board to sink down. Once the solder melts, the board should get attached. Just going to use two hands because we do not want to have to do this again. Okay, so I can see from the sides that it's sunk down and everything seems to be attached properly. I'm just going to give it some extra heat. Make sure that everything has floated. I think it's looking good. So now at this point, I could give the board a nudge to see if it will float, but I really don't want to take that chance. So we'll let it cool down and then we'll inspect it. Everything looks attached. Perfect. Perfect. Okay, then we'll let it cool down and then we'll inspect it. All right, now that the board's cooled down, let us take a look at the sandwich board and see if everything is attached properly. All right, that looks good. You can see all the solder pads are nicely attached. Excellent. The wing needed a bit more heat. Okay, let us quickly reheat the wing, make sure it is attached. Perfect. Now it got attached properly. Just gave it a quick little poke and I made sure. I'm going to do the same thing with the other side, and this time I'm going to go a little bit slower and just focus on the sides that I think didn't get attached fully. This top corner looked a little off, but it should be good now. I want to be careful and not nudge it with the hot air tool. Okay, I think that should be good. All right, it's cooled down enough. Let us inspect it under the microscope and hopefully It's good.
There has been an exploit that essentially allows someone.
Excellent.
Hack DDR6 or GDDR6.
Now all the solder pads look attached. These guys at the bottom don't look fully attached, but that may be because there's a slight warp in the board. These guys at the top look squeezed down.
Well, the initial thing is that causes.
Okay, so we're gonna have to fix this before we can proceed.
Do you remember way back in the day you learned about the iPhone exploit that you could trigger it flips in memory in order with like the corrected PDF or something, and use that to virtualize the CPU on the iPhone and use that to execute arbitrary code? You could do the same thing on a PC with this.
All right, so what we're gonna do is we're gonna try and manually squeeze down just this corner a little bit so that it attaches to the board, but we don't want to overheat the rest. So I'm gonna use low heat, 300 Celsius at 60 airflow. I'm gonna watch it from the side here and press it down once I can see the solder melt. But if I press it down too much, it will cause short circuits. So I have to be very careful with this. All right, it's melted. Now I'm able to press it down. I think that should do the trick. Then we'll do the same thing here.
Yeah, there's no CPU level exploit. That achieving the same thing for it is and use human measures for that you have back in the CPU.
Okay, that should have done the trick. Now once it cools down, we'll inspect it again and make sure that everything is properly attached.
Yeah.
Yeah.
Oh.
All right, let us see. Okay, now this looks well soldered. We do have a couple of solder balls that leaked out. It should be okay. Bottom board is looking a little separated. Wonder what happened there. Damn. Well, I'm not very happy with how this job went, but I guess at this point we will power it on and we'll see without the CPU. Before we power on the board without the CPU, let's put that coil back on and we'll make sure, because we need that coil in order to put power into the board. I almost forgot. And we'll leave that coil low melted. It should be fine. All right, that coil is good. Okay, before powering on the board, let us confirm that the short has been cleared. So with the red probe on ground, if we check that same coil with VPH power, it's now 0.282 voltage drop to ground, which means that short's gone. Excellent. So that is a good sign. Now, let's plug power into the board. Okay, we also don't have that immediate power draw, which is good. Excellent, excellent. Now, yeah, the first pin is the power button. Okay, let's see if we have voltage at the power button. That will also be a good sign that the power is coming in from the top board to the bottom. And make sure this remains plugged in. That connector is awfully stupid. It gets disconnected so easily. Okay, we have 3.6 volts at the power button. So power button has voltage. Now let's power this on and we'll see what it does. Excellent. So if we power it on, it draws about 4 milliamps and back to 0. That is normal. This is fantastic. The top and bottom board soldering went well. And now we can proceed with reballing the CPU and RAM. All right, so first we're going to prepare the top side of the CPU. gonna apply some low melt.
And for that MacBook, when will they use it?
Now we want to make sure we don't scratch the surface of the CPU in any way. So we're just gonna first tin the pads on top of the CPU, and then we'll braid it to remove the excess low melt, and then we'll use hot air to remove the underfill. Now, because the bottom of the CPU likely has some big pads, it's not gonna get clamped as easily. So let's just clean up the bottom of the CPU. We'll get rid of those big balls, or we could start by cleaning up the bottom of the CPU first, and then we can come back to the top. Regardless of which way we work first, both have to get done. So we're gonna do the same thing. We're gonna tin all the pads on the bottom of the CPU. And then if possible, we're gonna put those capacitors back, because the goal of this job is to give the customer a full repair if we can, not just data recovery. I will leave that guy crooked for now, because we'll use hot air to straighten it after. Now let us braid all the pads that are not underfilled, and we'll be able to get rid of the excess solder. Oh, and we took that capacitor off. Try to put it back. There we go. Okay, that is good enough for now. Let us wipe the top of the CPU. Now when we're wiping it, we want to be extra careful, because we've got those capacitors and we don't want to rip them off. That went quite well. I'm going to use 265 Celsius at 60 airflow to clean the underfill. Because I've tinned all those pads with low melt, they should come off with relative ease, or they should melt rather quickly. But you still have to be careful, because some of those underfilled pads won't get tinned, and then if you're too rough, you risk taking off the solder pads from the CPU itself. And that is really difficult to fix. But so far, it's working okay. Wonderful. The underfill is coming off nicely. Now those caps have all been low melted, so they're going to melt pretty quickly. So we have to be extra careful. This guy in the center should be all right because those pads did not get touched. Excellent. Most of the underfill is off. So now we're going to put a bit of flux on there, and then we'll put the capacitors back. Actually, we'll move that single guy back, and then the one that's missing, we'll put it back on in the end once we're done, because you don't have to deal with it at the moment. Now the next step is we're going to tin these pads and apply low melt and braid it once more. We want to take all the low melt off, and then we're going to apply some leaded solder to those pads and then reball it. And all the oxidized pads that aren't getting tinned, we're going to scratch them gently and make sure that they are tinned as well before we proceed. Because if we leave the oxidized pads as is, when we go to the Reball the CPU, it will not accept fresh solder, and then the Reball will be a nightmare to say the least. Okay, let us scratch these pads. Now, even after scratching them, because they're sort of lower than the PCB mask layer, they're not going to get tinned that easily. But when we go to reball it, the solder balls should stick to those well enough. All right, let's braid the CPU once more. We'll use the fresh side of a braid, though that is fraying. So Got one more stubborn solder pad right here. Okay. Okay, much better. Grab some fresh braid, because that one is frayed open quite badly, makes braiding the CPU a little more painful. There we go. That is working much better. Now, getting in between these capacitors is always a little painful, but doable. So the technique is, if you come in at an angle and just try and touch with the iron in between those caps, you'll be able to do it without disturbing the capacitors themselves. Okay, that went well enough. Let's wipe and clean it. Get rid of this underfill. Awesome, that's looking pretty good. Just have a few spots of underfill left on there. We'll clear that up. We'll continue with the other side. So foam pads will help clean that up nicely. Okay, that side looks good. Just have this side. Excellent. All right, all the underfill has been removed. So now let's just scratch the oxidized pads to make sure that they will either take solder when I tin the board when I tin the board shortly, or they'll take the solder when I reball the board. You have to be very, very gentle when you do this. You don't want to scratch the PCB. But thankfully, we don't have too many oxidized pads to deal with, so this was fairly straightforward. Awesome. Bottom of the CPU is almost ready. I'm gonna apply some flux and tin all the pads again, and then we'll put the missing capacitor back. I had set it aside on my desk. Now, because we're going to use leaded solder to tin the CPU, or to reball the CPU, I'm going to tin the pads with leaded solder. Damn it. Two of these guys came off. We may have to use hot air to put them on. Let's see. No, that one went on nicely. Let's see if this one also works. Perfect. Okay, we put both of them back on. Now, the goal behind tinning all the pads with some leaded solder before we reball it is it just makes it easier for the solder to stick to the pads. However, because those pads are a little sunken in, it's proving a little bit more stubborn than I would like. But this will still work better than having a bare board. Okay, at this point, the bottom of the CPU has been prepared. Let's clean it, and then we'll do the top side. And then it's just reball and install. Yeah, not many pads got tinned there. But still. Should be okay. Let's do the top side as well. So same thing. Now, because on the top side we're going to be putting the RAM on, we're just going to braid it and leave it as is. Actually, I just realized. Yeah, we haven't braided the top side yet. So let's do that first. And then we can take the underfill off. I believe we had started braiding it, and then it was proving too wobbly because the CPU had a big ass solder ball under it. So we needed to clean the CPU first. Okay, so we're going to use the same hot air temperature, 265 Celsius at 60 airflow. And we're going to gently scrape the underfill off. Now, we want to be careful. We want to make sure we don't go too deep. Otherwise, you will scrape the PCB mask on the CPU, and you will have a whole bunch of problems. All right, most of the underfill has been removed. So let us tin and braid these pads. And then we'll clean it, and that should be good. That's the CPU prepared. Now, if you've got any oxidized pads on the top of the CPU, you can't wait until a reball before you fix them, because that's where the RAM's going to attach. And if those pads aren't shiny, the RAM will not connect. So usually I've found that these guys, even the oxidized ones, clean up fairly easily, because I think they rest on the surface of the PCB instead of being recessed like the pads on the other side. So now that they've been cleaned, let's wipe it and make sure any underfill remnants are removed. Then we'll clean it and set it aside for the reball. Wonderful. Top of the CPU looks perfect. Let's clean the bottom of the CPU as well. And then we'll set it aside. We'll clean the RAM, and then we'll reball both and put them on the board. Beautiful. Okay, now let's clean the RAM and prepare it. gonna remove this layer of underfill because it's already coming off. All right, let's braid it. This piece of braid is almost done. Okay, now we'll use the same temperature to clear this underfill. Should come off nicely, easily. Now let's just scrub it down, make sure all the underfill's been removed. Fantastic. Okay, you're gonna tin it with leaded solder, just like the CPU. And we'll clean it and it should be ready for the reball. God damn it. I ended up scratching that with my iron right at the last second. Fuck. This is why we don't want to rush on doing this job. Now I have to braid this frickin' thing again and then clean up and mask. Man, I'm such an idiot. It was good. Didn't need to mess with it. And then messed with it, made it worse. Oh, let's fix it. It's not bad. It's not ruined. But it's definitely not a good thing. Yeah, it's too much. Too much. Well, at least we had that recording. So it's not the best, but not the worst. All right, let us reflow everything. So we'll put some flux on the CPU, flow it, then clean it, then reball the RAM, do the same thing. All right, that is a perfect reball. Let us check the CPU, make sure we don't have any bigger or smaller balls here. Nothing got there. And go. All right. Reball is complete and it is perfect. Excellent. Okay, let us reball the RAM. I think we should have just enough to do this. Maybe not. Phew, we had just enough paste left in our tool. Well, if it works, it ain't stupid, so he did it. All right, let us reball the RAM. Perfect. Oh, two solder balls did not attach. Of course, they didn't. Perfect. Now they're attached. All right, now let's take it off our stencil. Let's add some flux and reflow it. Wonderful. The RAM reball is done. Let's clean it and then inspect it. Then we'll put it on the board. And finally, at the end of our journey. Beautiful. Let's inspect the balls. You know what? I'm gonna just do compressed air. I'm sick of picking up tiny hairs left on there by my microfiber cloth. It's freaking frustrating. There, that's so much easier. Should have done that with the CPU. Oh well, next time. Wonderful. The RAM looks perfect. Okay, let us put it back on the board. All right, we're at the last step. Gonna solder the CPU, RAM, and the UFS in that order back onto the board. So we're gonna put a bit of flux on the board, and I'm gonna spread that flux using my paintbrush. We want a thin layer of flux on the board, not too much, because if I put too much flux on there, the CPU will float and dance around on that flux, and then I'll have problems attaching it. So just enough that all the pads are covered, but not too much. This is good. Now let's put the CPU on the board. And we want to make sure it's lined up correctly. All right, this is how it goes. I'm gonna make sure. I'm gonna do my best to position it directly on top of the pads, but even if it's not 100%, once the solder melts, surface tension will pull it into place. So to put the CPU on, I'm going to use 380 Celsius at 80 airflow. Let's make sure it's centered properly. That looks good. Let's begin. Now, when the solder melts, the CPU will sort of sink lower or settle down, and you'll see the flux seep out from underneath it. So that will be our indicator that it is soldered properly, and then we can nudge it and make sure that it's floating freely. If it jumps back into position, that confirms that the CPU is soldered on properly. So there, I just saw it move. So now let's poke it gently. And it moved back. CPU is good. Perfect. Now let's put the RAM on. So we're going to do the same thing with the RAM, just a thin layer of flux. And while this board is still hot, the flux will instantly liquefy, so it will be easier to put just enough on. Now the orientation dot for the RAM is in the bottom left corner. There it goes. I'm gonna position it, and then we'll use the same heat and airflow to put the RAM on. Now with the RAM, when we nudge it, we gotta be extra careful that we don't push on the CPU, because if the solder under the CPU is melted, then we could just undo all the work we've just done, reballing it and putting it on the board. We're going to keep an eye out for the same indicator. All right, it's melted. Let's nudge it. Perfect. The RAM is on. Now it's time for the UFS. And because the UFS is so sensitive to heat, we're going to use a lot lower temperature to put it on. So I'm going to use 310 Celsius at 80 airflow, and that should be more than enough to get it on there safely. So the orientation for the UFS on this board is bottom right corner. Gonna line it up with that F on the board. Oh, come on. Perfect. Let's lower the temperature. Okay, let's nudge it and make sure. Perfect, the RAM is on. I meant the UFS is on. There. Okay, once it cools down, let us power it on and we'll check. We're missing an antenna in the top corner. I'll put that back on once we've confirmed that it works. Okay, let's take a look at the solder pads. And look at that, it looks beautiful. The RAM and the CPU are beautifully attached. Every single one of those solder balls is nice and connected and perfectly straight, perfectly aligned. Wonderful. All right, fingers crossed that it works. This has been way too much work. Okay, so the board has cooled down. This is our tester housing. Let's power it on and check. If everything has worked out, this board should boot. I'm going to connect the LCD and I guess the charging port connector, because I'm not sure which one of these two is the LCD. I think it's the right one. But all right, moment of truth. Always nerve-wracking. Gonna change this tape. That connector is very loose, so it doesn't stay plugged in. So kind of need some Captain tape to hold it in place. All right, this should be good. Okay, plug the board in. Okay, first sign is good. There's no immediate power draw. Now, let's power it on. Awesome. We have Samsung logo. Excellent. However, is it going to boot? If it doesn't boot, I may need to reball that sandwich board, but fingers crossed. So far, so good. Amazing. Phone powered on successfully. Data has been saved. Awesome. Awesome. This was a lot of work. Let me boot it on again. I'm going to take a photo. Oh my God, this was a painful amount of work, but it works. Amazing. Amazing. Man, that was so much fucking work. But it's fixed. Device boots on. If you have a device from which you need data recovered, you can send it to us. We accept mail-in repairs from all across Canada and the USA. The link is in the description, and thank you for watching.